Greetings, special greetings to every one of you today. My name is Easy Maths Tutor Ejiro John, and I want to talk to us today about index notation. So, numbers can be expressed in index form. We have very large number, and we can simplify them by writing them in standard form. We have very tiny numbers that instead of writing as tiny as 100 digits, as tiny as 50 digits. Okay, so if we want to shorten it, we can also express it in standard form. So now this is a kind of shorthand way of writing digits in mathematics. For instance, you may have a digit that looks like this: 5 times 5 times 5 times 5 times 5, 6 times. Now we're going to express it as 5 raised to the power 6. And also you could have something like m times m times m times m times m times m times m. If you count it, I said m raised to the power 9 times. So 5 raised to the power 6 and m raised to the power 9 are all known as index forms of writing multiplication calculations. Now, while 5 and u are the basis, 6 and 9 are the indices or the power. We'll call them the index, we'll call them the power. So we also have other examples like fraction, recurring fractions. Maybe you have 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2 3 times. Okay, so that will be 1 over 2 whole bracket raised to the power 3. And then also we could flip the 2 over from the denominator to the numerator, which will give us 2 raised to the power minus 3. So when you flip over the fraction from the denominator to the numerator, then the power becomes negative. It's also called an inverse index. Okay, now let's do a very quick exercise. We're going to simplify an index and also use our calculator to verify the correct answer. Okay, so let's assume we have 3 raised to the power 2 times 3 raised to the power 5. Now the value will give us 3 raised to the power 2 plus 5, which is 3 raised to the power 7. Now use a calculator and multiply 3 2 times and multiply by 3 5 times. What will be your answer? Okay, that's your answer. Okay, use a calculator and check 3 raised to the power 7. What will be your answer? I guess it's the same answer, right? Correct. So that tells us that this operation of index can be used to solve various equations. So generally, there's a way to express these indices. Let's call our base a and let's call our power n. So if a multiplies itself n times, therefore we'll have a raised to power n. Now we have different laws of indices. The first law is the multiplication law. This means that if you multiply a number of times the same number another number of times, it's equal to the number raised to power the addition of the two powers. Okay, so that is our multiplication law. So our base must be the same for us to be able to add their powers. So that gives us the multiplication law. We shall quickly solve a problem. Okay, so we have y raised to power 3 times y raised to power 4. So that gives us y raised to power 3 plus 4, which is equal to y raised to power 7. Let's take another quick example. We have 4x cubed times 3x squared. So how do we multiply this? We expand it, okay? So we have 4 times x cubed times 3 times x squared. So we're going to shift the 4 and the 3 to one side, take it together. So we'll have 4 times 3 times x cubed times x squared. So we're going to treat the functions of x differently. So we'll have 4 times 3 times x bracket in the powers 3 plus 2, which is equal to 5. So that gives us 4 times 3, 12, times x raised to power 5. So our final answer is 12x raised to power 5. Now let's use another method. A simpler method but longer, okay? So we'll say 4 times x times x times x times 3 times x times x. So if we shift 4 times 3 to one side, take it to one side since they are like terms, and then we take x times x times x times x times x to another side. So 4 times 3 will give us 12, and then the remaining x will count it. So we have 1, 2, 3, 4, and 5. So that gives us 12 times x raised to power 5. And now let's look at a third problem. We have y raised to power 9 all over y raised to power 2. So how do we apply this law in solving the multiplication law of indices and solving this problem? Okay, it looks like a rational term, but we could use the multiplication law to solve it. So we have y raised to power 9 all over y raised to power 2. So let's go ahead and check it out. Okay, now we'll start from the longer method. Okay, so we'll say y times y times y 9 times all over y times y. So if we cross out the two y's at the denominator and cross out another two y's at the numerator, we're going to have 7 y's left, which is y times y times y 7 times. So that gives us y raised to power 7. Now the second method, y raised to power 9 times 1 all over y raised to power 2. And remember what I said at the beginning, that if you flip over the fraction, the power changes, okay? So we're going to flip over 1 over y raised to power 2. So if we flip over 1 over y raised to power 2, we're going to have y raised to power minus 2. So our answer will be y raised to power 9 times y raised to power minus 2. So if we apply the multiplication law of indices, we're going to have y raised to power bracket 9 minus 2, which is y raised to power 7. So I'm going to give you an assignment right now. So I want you to solve this problem. Find or simplify x raised to power minus 8 times x raised to power 7. What is the value when you simplify 8 raised to power minus 8 times, what is the value when you simplify x raised to power minus 8 times x raised to power 7? And I'm also going to give you another exercise. Simplify leaving your answer in index form, y raised to power 7 times y raised to power 9 all over y raised to power 6. Now before we go right ahead, I want you to just click on the subscription button and click on the like button and also share with your friends so that they can learn also what you have learned. Thank you. And now we're going to the second law, which is the division law of indices. To divide any two real numbers in index form that have the same base, you have to subtract the powers or indices of the denominator from those of the numerator and raise the base to this difference. Okay? For instance, if we have a raised to power m divided by a raised to power n, our final answer will be a raised to power m minus n. But you have to be careful here. This law applies only to the division of numbers in index form and not to subtraction of such numbers. The law does not hold for subtraction, okay? It holds for only division. So now let's solve some examples. Let's solve this question: 25ab squared all over 5b. 25ab squared all over 5b. So what are we going to have? We'll first of all expand it. Okay, let's use the normal indices method to do it. We're not going to use the long method. We're going to advance to a fast and quick method of solving this. Okay, so we'll say 25 all over 5. Separate those terms, 25 all over 5, and then we'll also separate ab squared all over b. Okay, so 25 all over 5 will give us 5, and ab squared all over b will simply give us ab, because the b in the numerator had to cancel out one of the b's in the square, leaving us with ab. So at this point we didn't necessarily use our index method. This was a very simple problem, so we didn't need to use the index method. But our next question goes like this: 3 raised to power 12 divided by 3 raised to power 7. Now we're going to say, since the bases are 3, they are equal and they are 3, and then the operation is division, we can apply this law. So we'll say 3 raised to power 12 minus 7, which will give us 3 raised to power 5. So you can imagine, if we were to expand this number, we will not have enough space in our notebook or enough strength to write out the full numbers. So indices makes our life very, very simple and very easy to work with. Okay, so let's do our third example. Our third example is 3y raised to power 30 divided by y raised to power 15. 3y raised to power 30 divided by y raised to power 15. So we'll say 3 times y raised to power 30 all over y raised to power 15. So we'll isolate 3, so we'll have 3 on one side, and then we'll open a bracket and we'll write y raised to power 30 minus 15, bracket close. So we'll have our final answer as 3y raised to power 15. And so now I'm going to give you some simple exercises so you can practice on your own. Okay? So when you practice them, write the answers in the comment section and I'll mark you correct. Or you can contact me by sending it to my email, easymathsonline@gmail.com. Now our first exercise is 8 raised to power 40 divided by 8 raised to power 27. 8 raised to power 40 divided by 8 raised to power 27. What is our final answer? And then we have arrow raised to power 21 all over arrow raised to power 19. Arrow raised to power 21 all over arrow raised to power 19. Simplify these problems, leaving your answer in index form. And now for our third law. Our third law of indices is called zero power. Okay? So if you have a number raised to power 0, what will be your answer? It will be equal to 1. Any number raised to power 0 is equal to 1. Now let's prove that. Assuming we have x raised to power 3 divided by x raised to power 3. Now let's apply our division law of indices. So we'll have x raised to power 3 minus 3, which will give us x raised to power 0. And then we know that x raised to power 3 all over x raised to power 3, or x raised to power 3 divided by x raised to power 3 will give us 1. This implies that any number raised to power 0 will naturally give us 1. So, our simple examples. 2 raised to power 0 is 1. 100 raised to power 0 is 1. 50 raised to power 0 is 1. And so on and so forth. And so we'll quickly go on to our fourth law, which is our negative power or our negative indices. And this states that for any real number a raised to a negative power, let's say minus m, is equal to the reciprocal of that number raised to the positive number. Now, for instance, we have a raised to power minus m will be equal to 1 all over a raised to power m. And also the inverse is also true for that. So this law is simple and straightforward and something that you can simply do, okay? So we have our fifth law. Takes us to our fifth law, which is raising numbers in index form to a power. That is raising a number already raised to a power to another power. Okay, so this law states that to raise any real number a in index form to a power, we have to multiply the two powers and raise the number to their product. Okay, we have to multiply the two powers and raise the power to their product. So the law goes like this: a raised to power m in brackets raised to power n will give us a raised to power m times n, which is equal to a m n. Now we have some quick examples. We have 2 raised to power 3 in bracket raised to power 4. So how do we get that? We will say 2 raised to power 3 times 4 will give us 2 raised to power 12. Another example, we have 3 raised to power 5 in brackets raised to power 3, which will give us 3 raised to power 5 times 3, which is equal to 3 raised to power 15. Okay, so we have 1 or 2 examples I'm going to solve for us. Okay, so let's take this example. We have 2 raised to power minus 3 into bracket raised to power minus 6. So how do we get this answer? Our answer is 2 raised to power minus 3 times minus 6. So we know that minus 3 times minus 6 will give us 18. So our final answer is 2 raised to power 18. Now I'll solve the second example, which is 2 raised to power minus 8 into bracket minus 1 all over 2. So our answer will be 2 raised to power minus 8 times minus 1 all over 2. and you know that minus 8 times minus 1 all over 2, when you cancel 2 out of 8, or when you divide 8 by 2, you will have 4. So our answer will be 4. 2 raised to power 4 is our final answer. So I want you to do this simple exercise, okay? So we'll say 7 raised to power 7 into bracket minus 1 all over 3. When you simplify that, what will be your answer? 7 raised to power 3 into bracket raised to power minus 1 all over 3. What will be your answer? Give me your answer right in the comment section, okay? Or send your answer through an email to me at easymathsonline@gmail.com. And so now, in the spirit of indices and index forms, we're going to find whole numbers in standard form. Whole numbers in standard form. Now, we have some numbers that are so large that will not even have enough space, even if you have a paper as long as from here to London. It won't be enough to write that number. But you can always simplify that number in a form which we call standard form, okay? So to write a number in standard form, express it as a number between 1 and 10 multiplied by 10 to some number, okay? For instance, we have 1 million, okay? That's 1,000,000. That's 1 million, okay? So 1 million will be, if we expand it, it is 10 times 10 times 10 times 10 times 10 times 10, 6 times, okay? So therefore, 1 million is equal to 10 raised to power 6, okay? So now let's do the same for 1 billion. 1 billion is 1,000,000,000,000, 9 zeros, okay? So if we expand it, we'll have 10 times 10 times 10 times 10 times 10 9 times, okay? So that will give us 10 raised to power 9, okay? So we have 1 trillion. 1 trillion has 12 zeros. I can't begin to even start, okay? Just count me out of that, okay? So we'll say 10 raised to power 12. Okay, welcome back. So how about if we have a number that is not regular, like 1 million, 1 billion, 1 trillion, just a normal number with different digits. For instance, 135. How do we convert that number to standard form? Okay, what we're going to do, we're going to look for the decimal point of that number, okay, and we're going to move it to the left, okay, and then we're going to count how many times we move that number, and then multiply by 10 and raise the power to the number of times we move that number, okay? So if we have 135 and we want to convert it to standard form, our answer will therefore be, assuming we move it 2 times, we'll have 1.35 times 10 raised to power 2. So that's the standard form for 145 in standard form. We could also move it 3 times, which will give us 0.145 times 10 raised to power 3. Okay? Now, if you move your decimals to the left, you find out that the power will increase positively. If you move your decimal to the right, your power will be in negative form. Okay? For instance, if I say, let me convert 135, okay? I will say 100, and maybe I move my decimal 2 places to my right. That will be 100, and that will be 13,500 times 10 raised to power minus 2. 13,500 times 10 raised to power minus 2. So when I move my decimal to the right, I have negative powers. When I move my decimal to the left, I have positive powers. Okay, so if I want to define standard form is a way of writing down very large and small numbers in the form a, assuming, times 10 raised to power n, where n could be a number less than 1 and a number greater than 1. Okay, it could also be a number, positive number or a negative number. So at this point, we're going to solve some examples. So we'll solve this one. Put these numbers in order of size, starting with the largest number. Okay, so we have 0.09, we have 5 times 10 raised to power minus 3, we have 0.5, we have 8 times 10 raised to power minus 4, and we have 5.4 times 10 raised to power minus 2. So we're going to expand them, and then we're going to rearrange them in the order of size, starting with the largest number to the smallest number. So obviously 8 times 10 raised to minus 4 is smaller, while 5 times 10 raised to power minus 3 is next, and then 5 times 4 times 5.4 times 10 raised to power minus 4 is next in line, followed by 0.09 and finally 0.5. So if we arrange it, that is how it's going to look. So I'm going to give you some work to do. These numbers are written in standard form. Convert them to ordinary numbers. 2 times 10 raised to power 3. Okay? Convert it to ordinary numbers. Convert 3.5 times 10 raised to power 0. Convert it to an ordinary number. And then write these numbers in standard form. 9,700,000,000. Write it in standard form. Then also write this number in standard form. 170,200. Okay? And also convert this number, which is in standard form, convert it to an ordinary number. Convert 8.78 times 10 raised to power minus 3, convert it to an ordinary number. That is, write it in ordinary form, not in standard form. And also write this number in standard form. 0.00081. 0.00081. Write this number in standard form. Okay? Next, we're going to learn squares and square roots. Don't forget to subscribe if you haven't done that already. Like this video and share with your friend. Thank you. So, squares and square roots. A square number is obtained by multiplying a number by itself. Okay, a square is a number. A square is obtained by multiplying a number by itself. So if I say, what's the square of 2? I'll say the square of 2 is 2 times 2, which is 4. Or whenever a number is raised to power 2, then you have the square of that number. Any number raised to power 2 is the square of that number. 5 squared is 25. 10 squared is 100. 9 squared is 81. And so on and so forth. Then on the flip side, we have the square roots. The square roots have to do with a number that divides another number to give us the original number. A number that divides a number to give us the original number. For instance, we have 4. If 4 divides 16, it gives us 4. That means the square root of 16 is 4. a number divides it by itself to give us that same number, it's known as the square root. So that's that. But if a number is raised to a power half, the value of that number is its square root. So if we say 16 raised to power half, the value will be 4. That's its square root. Okay. There are simple ways for us to find the square root of numbers. We can use index method to find the square root. We could also use LCM method to find square roots. Let's take an example. Find the square root of 324. We're going to use the LCM method. First of all, we'll divide 324 by 2, which will give us 162. And then we'll divide it by another 2, which will give us 106, which will give us 81. Okay? So now what will divide 81? We have 3. Okay? 3 into 81 will give us 27. 3 into 27 will give us 9. 3 into 9 will give us 3. 3 into 1 will give us 1. So now we have a set of numbers which is 2 times 2 times 3 times 3 times 3 times 3. We're already seeing the pattern, a square pattern showing up, okay? So we have 2 times 2, that will eliminate 1, 2. So we have 3 times 3, eliminating 1, 3. We have another 3 times 3, eliminating another 3. So finally we're going to have 2 times 3 times 3. That will give us 18. So this is the manual method of finding the square root. 18 is the square root of 324. But if we're using the index method, means that we're going to raise this function to the power of half. Everything is raised to power 2. It's a square. So if we divide those powers by half, we'll have 1, okay? So we'll multiply those numbers and then we'll have our square root. Square root of fractions. The square root of a fraction is the same as the square root of the numerator divided by the square root of the denominator. Simple as that. Let's solve some examples. Determine the value of the square root of 36 all over 169. We know that 36 is 6 times 6, and we know that 169 is 13 times 13. The square root of 6 times 6 all over 13 times 13 will simply give us 6 all over 13. And so I'm going to give you a quick example to solve. Help us to find the square root of 27 all over 48. So let's see how you go about that. I believe it's not going to be too difficult. Write your answer in the comment section or send me an email on easymathsonline@gmail.com. Also, help us to find the square root of two whole numbers, 7 all over 9. Let me give you a quick hint. You're going to convert this improper fraction to a normal fraction. You're going to convert this mixed fraction to improper fraction. Then from there, you're going to find the square root of the numerator and the square root of the denominator. Then once you do that, you'll get your final answer. I'll do one example in order not to get us too confused. We have find the square root of one whole number, 9 over 16. So let's convert this mixed fraction to an improper fraction. So what do we have? We have 16 times 1 plus 9 all over 16. So that gives us 16 plus 9, which is 25 all over 16. So let's break it down. 5 times 5 all over 4 times 4. Our square root, our final answer will be 5 all over 4. Converting it back to mixed fraction, we'll have one whole number 1 all over 4. I'll do one more example. Let us find the square root of this fraction, 384 all over 54. Find the LCM to see whether we can pull out the factors of this number. If we find the LCM of 384, 4 into 384 will give us 9. Remember 36. So 38 minus 36 is 2. So we have remainder 224. So we have 96. 96. Let's use another 4. We'll have 2 here and 4 here. Another 4 will give us what? Will give us 6. 2 will give us 3. 3 will give us 1. So we've gotten our first factors. Then we have for 54, we have 6. 6 goes into 54 9 times. 3 goes into 9 3 times. 3 goes into 3 1 time. We're going to rewrite our square root. So 384 gives us 4 times 4 times 4 times 2 times 3. 54 gives us 6 times 3 times 3. Okay. We'll cancel out this 3. Cancelling out this 3. We have 18. We have it like this. I'm going to further break down 6. Further break down 6. So we have 4 times 4 times 4 times 2 all over 2 times 3 times 3. This 2 will cancel itself out. This 2 will cancel itself out, giving us this of this. You know, this will single this out, giving us 4. This 4 is 2 times 2, so it's singled out, giving us 2 all over what? 3 times 3, giving us 3. So our final answer is 8 all over 3. That's the square root of 384 all over 54. Thank you for watching. Just click on the next video for more interesting topics in mathematics. God bless you. Don't forget to subscribe to this channel and like and share with your friends so that they could also learn as well. Thank you. See you next time. Bye.